is Algebra 2. We are on Lesson 1. This is the current notes that we're on. Look at where we are. We are on 1-7, evaluating inverse functions. We have just a bunch of lessons, lesson after lesson, until we hit the quiz and then into a test. Chris?
Wait, I have a question. Don't you only record when one of us is in here?
I record just in case for next year they need a lesson.
So you record everything now from now?
I do, yes.
I didn't know that.
So, evaluating inverse functions. So, first of all, what are inverse functions? The way that I like to think about inverse functions are it's going backwards. It's the reverse. So, inverse functions, and you're writing this down with Mr. Sindel right now, inverse functions are reverse functions. I cannot spell reverse. Reverse functions. If normal functions go forward, then inverse functions go backwards. So maybe if you want this word, you don't like reverse, maybe you like the word backwards. It goes the opposite direction. And then here's a key. This key will be used tomorrow too. You find inverse functions by doing the following thing. And this is super important for our lesson tomorrow, but it's only semi-important for today. You have to switch the x and the y. So switch. By switching the inputs with the outputs. And if you don't like the word input, maybe you like the variable x and outputs variable y. The x's and y's, they switch. So tomorrow I'm going to ask you, how do you find inverse functions? And you're going to tell me by... Perfect. So you'll be ready. By the way, tomorrow I'm getting observed by Miss Sasson, so be on your best behavior.
Dude, there's no way.
All right. So by the way, not all functions are invertible. Some functions are invertible, some are not. Do you guys want to see an example of a function that is not invertible?
Yes.
Let's see it. So here was our warm-up. We had a normal parabola. If I were to graph its inverse, it looks like this. Boom. That dashed blue line. Why is this not a function? Quiet raise hand for XP. Why is this not a function, that dashed blue line? Raise your hand if you know why. Eva.
Because if you do that line thing, it goes through twice.
Yes. It does not pass the vertical line test. If I were to have a line, say, I'm just going to go right here, x equals 4. This line passes through that blue function twice. If it passes through a function more than once, it is not a function. So when I took the inverse, by the way, yeah, the blue dashed line is an inverse of the red function. Some inverses are not functions. That is just one example. All right, so coming back here to our notes. Not all functions are invertible. What I want you to do is just to do a quick picture. Look, that function is not invertible. Look, this function that goes straight up and down, that one obviously is not a function. This is not a function. This is not a function. Just be careful of things that are not functions. Something that's not invertible. So these are not function. These are not invertible. This is not invertible. This is not invertible. Oops. A flat line, a flat horizontal line. That's not invertible. So just be careful. Not super important to know for the homework set, but it is something that you need to be aware of. All right. So if my definition of inverse functions is just to go backwards, then let's try this out. Let's first go forwards. G of 0. What is G of 0? I have this 0 and then I apply this G to it. Quiet raised hand. What does it turn into? James? G of 0 is 4. It is 4. And I need to start giving out XP, otherwise I'm going to forget. So let's come here to Algebra 2. People that participated on the warm-up, that is going to be... James participated in the warm-up. Fiona participated in the warm-up. Who else participated?
I did.
Chris?
Wait, I just...
Eva? Anyone else?
What about the bell?
Oh yeah, I'll give all y'all 10 XP. And we just had an answer. James just answered now. So that's 50 XP. And Fiona, did you answer one up here? I feel like you answered something, but I don't remember what it was. If I remember, oh, it was the warm-up? Okay, I think I gave you the warm-up Okay, so g to the negative 1 of 4. This is how you write an inverse function, to the power of negative 1. This is saying, what is the inverse of g when I plug in 4? So now you're going backwards. Now instead of starting in the blue circle, you're starting in the yellow circle. Look for 4 and see if you can go backwards. Quiet raised hand. The inverse function of g of 4 is what? Geo? 0. There it is. Pretty straightforward, right?
I want
Yeah.
Here's something that's even harder. This is a composition of inverse and normal functions. So first, we do the inside. G of 0, shout it out, is 4. So that means this whole thing, you can write over it, this whole thing is 4. Now this whole thing is turned into, what is the inverse function of 4? You already answered that. It is 0. This is what's happening in terms of the picture. I take g of 0 and I go to 4 and then I go backwards. If you go forward and come backwards, no matter what input I give you, even if this number isn't given to you, you know that you're coming back to whatever value that you started originally with. I started originally with 0, I went forward and backwards, and I ended back at 0. So let's try this next question. And I don't know why that happens. If I scroll down and then back up, sometimes it fixes it. It did fix it in this case. Okay, 23.12, I'm putting that into G. Uh-oh, Mr. Snell, 23.12 isn't in here. But I just told you the rule. When I do a composition of inverse and normal functions, you know how to get back. Quiet raised hand. What is the answer to this evaluation? Quiet raised hand. There's only 2 people that know. Again, let me restate what I just said. If I have my original input, I take the function and then I go backwards, I am left with whatever my input was. Andrea. It is 23.12, 23.12.
23.4.
If I have the function and I take the inverse of the function, they cancel each other out. This is how I want you to write it. They cancel each other out and I'm just left with 23.12. The problem set on Khan Academy today has these types of problems. Be ready for them. All right. So this is the key part. Inverse of normal function is just the input. It's a key thing to write down. That's why I started. But it's basically saying this in words. If I take the inverse of the original function, it's just the input. This was the input. It was 23.12. 23.12 is the answer. All right, I'm going to pause, make sure that we can digest. We just did a bunch of stuff. We know what an inverse is. We know how to find inverses. We know that some things are not invertible. And we know how to just look at a picture to tell what an inverse is. All right, we're digesting. Here we go. Example 2. This is with a table now. With a table. Normally, what we do when we have just f of something is we start with x, we start with negative 10, and then f of negative 10 gives us 1. Now we're going to go backwards. What do you think backwards means when I ask the question, what is the inverse of f when I plug in 5? Quiet raised hand. Backwards when I plug in 5. The inverse of f of 5. I want the answer with a quiet raised hand. Eva? 5. Thumbs up, thumbs down. Agree, disagree? Interesting. Some people did thumbs up, some people did thumbs down. So first of all, everyone got their 10 XP for voting. Second of all, Eva gets your XP, but it was an attempt because it is not quite correct. You only start with your input if you have a composition of an inverse with the normal. This is just the inverse. This is just going backwards. So can I get another quiet raised hand to do this one, James?
2.
2. How'd you get 2?
Because changing the input to the output. So you're just
So you saw this 5 and that evaluates the 2?
Yeah.
So you would be correct if I were to just ask what is f of 5. But we want to go backwards. So I'm going to give it to Fiona. 6. How'd you get 6? Backwards from 5, you get 6. So the output was 5, the input was 6. Now our input is 5, and our output is 6 because it was reversed. So the correct answer is indeed 6. Let's try a harder one. All right, I need to evaluate f of 2 plus the inverse of f of 0. So you need to evaluate both of these. This one is going forwards, this one is going backwards. We're adding those two outputs. Let's go with Geo.
9.
Tell me your work. How'd you get 9? What was f of 2?
So F2 is -10.
Negative 10. I'm going to write that below. Actually, I'm just going to do it right here. Bless you, bless you, bless you. Bless you. Oh my gosh. She's dying over there. And then the inverse of f of 0 was what, Geo?
It's 1.
Plus 1, because we saw 0 and we got backwards to 1. And then you said your final answer was
-9.
-9. Did you box it?
Yeah.
All right. There it is.
I didn't realize what it is.
Are there questions about how to do example 2 from a table? We know how to go backwards. We know how to go forwards. All right. Example 3, and then once we hit example 4, then things start heating up. Example 3. Now we're going backwards from a table. Instead of an equation, instead of a table, we're going backwards from a graph. I think I said table, didn't I? Instead of, we're going backwards from a graph this time. All right, so normally, this is how a graph normally works. Normally you go out on your x-axis, and then you find where you intersect the y-axis. So if I come out to -1, I come down to -5. So that's the order of operations. First x, then y. Now it's backwards. First y, then x. So instead of starting on the x-axis, start on the y-axis. So instead of going left and right first, we're going to go up and down first. So the inverse of g of -7. I'm going to plug in -7 on the x or the y. I don't know what were my instructions. And then I'm going to find where it intersects the graph. I need at least 3 hands before I call on someone. I see Fiona's hand. Another way of asking this question is, when I have a height of -7, what is the x-coordinate? I see Gio's hand. I need 1 more hand before I can call on someone. James has a half hand. That's 2.5. I need 3 hands. Full hand? Is that a full hand now? Okay, there's a full hand. Steph. -3. So you went down to -7, which is right here. And then you went out to where it intersected the graph, which happened to be right here. And then you looked up to see what the x-coordinate was, which was -3. That is correct. Fiona, you have a question? Giving her the okay? All right. I'll give this to someone else now. What is the inverse of g of 6? I want at least 5 hands before I call on someone.
That's so weird.
At least 5 hands. I see Gio's. I see Fiona's. I see Chris's. I only see 3 hands. 4 hands for James. 1 more hand. 1 more hand. I need 1 more hand before I call on someone. Someone else needs to find the answer. There's the other hand, Chris.
Wait, don't even call me. Never mind.
I want to hear what you have to say, Chris.
No, dude, I don't.
Okay, we don't have 5 hands then.
Yeah,
1, 2, 3. Now we actually have 5 hands. Andrea. 2.5. How did you get 2.5? Can you walk me through it? 6 in which axis?
Oh, it's on 2.
Y-axis. Okay, I'm up here. Right here, and that happens to be in between 2 and 3, which is exactly 2.5. Very nice.
Straight eyeball into it, so that's what.
All right, questions on anything that we've done on the front side of our notes? Questions? Everyone understands how to go backwards so far for all these problems? All right, this is the part where you put down your pencil, sit back, relax, and pay attention. You super need to pay attention because I am going to be making sure you understand how to do this very hard problem. We're going to graph the inverse here. How to graph the inverse. Now you're actually like materializing a graph instead of just analyzing a graph. Okay, to do this, I want you guys to notice what's happening here. What's up, James? I got it for Fiona. Oh, and Andrea? I think I got it for Andrea, but let me check if I did it because it's in my, that's delayed damage. Game feed, I gave her 50 XP right there. All right. Yeah, but thank you for reminding me. Okay, so, no, it's okay. So, take a look at what happened here. This was the original function. This is the inverse function. Everyone on the warm-up said it is either a rotation or a reflection. We don't know which one it is. Okay, let's look at our next example. This is your original function. This is the inverse. What do you notice? Be thinking about it in your heads quietly. What do you notice? It's definitely not something, it definitely is something. Be thinking, be thinking, be thinking, and we're going to the next example. This is the original equation. This is the inverse of that equation. What is the trick to finding inverses? I'm going to graph them all right now. What did you do? What do you notice about all of these graphs? What's the trick? Yeah, Gio, what's the trick?
You're just doing the opposite.
What do you mean by the opposite? All right, Andrea?
So X and the Y change.
The X and the Y change. What do you mean by that? They switch places. So I'm going to, you have the right answer. So let me, hold on, give Gio his. Let me explain that a little bit more thoroughly. Yes, the X and the Y switch places. Take a look at this. I'm going to ungraph all of these things and just look at one example. This was the inverse, so the red was the normal function, blue was the inverse. Look at these 2 points on my graph. 0, 2, and 2, 6. Everyone is paying attention. Chris, you need to be paying attention. Those were my original 2 points. Look at what happens when I do my inverse. What happened to my vertex? What happened to this little tip point, my minimum point? The minimum point was 0, 2, and now it's 2, 0.
Oh.
This point up here was 2, 6. Now it's 6, 2. Andrea, say what you said again now. The X and the Y change. And that's from our notes as well. Our notes at the very top, we said switching the X and the Y. That's how you find the inverse. And here is the shortcut. This is what you're going to write down in your notes. Look at this. This is the line y equals x. If I graph all of my functions again on top of this, notice that all of these red functions, if they were reflected with a mirror over this line, this dotted black line y equals x, they map onto these dashed blue lines. So yes, the definition is you switch the x and the y's and you can find it. But even better is it needs to reflect over this line y equals x. In pre-calculus and in calculus, I'm going to be asking you, what is the graphical representation of an inverse? And you will respond, it's the reflection across y equals x. You learned it right now. You haven't really applied it yet, but you did learn it. Let's go back and add that to our notes. First of all, it's just switching x and y. We already know that. But let's just write it down again. Graphing inverse means you switch the x and y coordinates. This is from Andrea. How do you say what Mr. Sindel said about this black line in your own words? Can someone regurgitate that to me? Something about this black line y equals x. Here's the function y equals x. What did I just say? See if you can recall it back, Fiona.
When like you're graphing the inverse function, it's reflected over y equals x.
Yeah, same as reflecting over y equals x. I'm going to write that down, what you said. Reflecting over this equation. I'm going to write it in red because it's important. Y equals x, which makes sense because the y and x are being the same, are the same. Y equals x means x equals y. They are interchangeable. So along this x-axis, if I were to graph a point here and take the inverse of it, it would be the same point. It's graphed to itself. That's a little bit higher level. We'll get to that in a sec. Okay, now we need to apply that knowledge to this type of graph. There are quite a few of these on Khan Academy. You will at least be doing one for the homework assignment tonight. What is the graph of the inverse? So, first, what are the coordinates of this point? Quiet raise hand. Easy XP here. James, this point right here. What are the coordinate pair? What is the coordinate pair?
2, -3.
2, comma,
Oh.
2, comma, -3, like that?
No, it's 3 now.
No, -3 over
-3, comma 2. Okay, thank you, James. Sure.
So I get like 50 cents.
You did 10.
All right, I need another coordinate pair. Another coordinate pair, Eva.
1,4.
1,4. All right, we know the x and y coordinates. Now I need to graph those x and y coordinates elsewhere. Fiona, what am I going to do?
We're gonna grab 2, -3,
2.
and 4, 1.
So here's 2, -3. I'm going to label it on my graph as well. You're going to label this on yours, so follow along. I'm going to pause here so you can catch up. Make sure that both of these points were labeled, and we're going to graph Fiona's 2, -3. She switched the x and the y because that is the inverse of that other point. So everyone is catching up, and then Fiona's going to continue on with the second half again. She's going to repeat it. What's that second point I'm going to graph?
4, 1.
4, 1. So I come out 1, 2, 3, 4. I go up 1, 4, comma 1. And I just need to connect those with a straight line. And that makes sense graphically. The way that I can visualize this to see if it makes sense is because when I graph y equals x, when I graph this thing right here, it is the reflection. You can clearly see this is just a reflection across y equals x. That's how I'm checking my work. I eyeball it, looks good, I give myself the thumbs up. All right, questions? All right, go ahead and write your summaries.